Okay, a couple of things to talk about before we get back into the slides. I saw a bunch of you are on Slack now. Some of you are working through getting the Raspbian installed in a virtual machine. A couple of people are running into some issues with a black screen type thing, and we have some solutions up there where there's like a special file you have to download to get it working on VirtualBox that you don't need on some of the other ones, but make sure you're all getting signed up for Slack. That's cuwcs.slack.com. Here, I'll put that on a slide. It's pretty important because I make all sorts of announcements and things like that up there, and if you're not on Slack, you won't get those. So go to cuwcs.slack.com, sign up with your CUW email, and then join the CSC200 class. I would also get the app for your phone and get the app for your PC, and make sure you turn notifications on for the 200 class so that whenever something gets posted in there, you get some sort of push notification letting you know that something got posted in there. That's how I do communication in class, and you can see here for 200 there's already been quite a bit of stuff posted in there, so if you didn't see that stuff, you're missing out already. Okay, questions about Slack? All right, let's see. Next, the book we're going to use in this class is free. We're going to follow an online book, so it's linked here, called Coursebook. And it follows something called Automate the Boring Stuff. Now, I'll point something else out. I gave you a link to it, but it's also somewhere in here on the main page. There is a Udemy course. So any of you have ever used Udemy, it's like one of those things that has like video courses that you can buy and download and go through stuff. I won't be using the Udemy course, but there is a January 2020 sale for it. If you click on that discount code, I think it's going to take you to Udemy. And I don't know what it costs, but I think the course comes out to like $12 or $14 or something like that. If you wanted to have an additional resource for class that has some video lectures that go through some of the drill assignments and things like that we'll be doing, not a bad idea if this is part of your how you learn. I won't be referencing the Udemy course, but it does follow the identical online book we're using. And there's some sort of deep discount for, I think it's $12 or $14 or something like that. It might even be $10. I can't see because I already purchased it. But in any case, something I'll bring to your attention, since it seems like they always have a code on there, so I'm guessing at the end of January it'll be a February 2020 code or something, but just in case, you have a couple more days to use that code if you want to get the discounted Udemy course to follow what we're doing in class. Like I said, not required. I won't reference it. We will be using the book in class, this guy. And I'm going to give you readings out of this guy. So the first couple weeks of class, we're going to be doing a lot of intro work. So I'm going to actually give you some readings to do to kind of get ahead a little bit. And if you notice, the first couple of assignments, like our first assignment is due on Friday, is a one-page little paper. What I want you to go out and research what is SQL. We're not going to necessarily talk about it in class for a little while. Eventually, we're going to do some programming assignments using SQL. But while I'm talking about background material in here, get you some points. You don't have to follow any sort of specific writing standard or something like that. Just don't copy the contents of your paper from some other website. You know, if you reference something, put it in quotes, give me some sort of reasonable format for where you got it from. But one page, double spaced, by Friday you should have a decent idea of what SQL is the punchline. And I think for Monday there's another writing assignment, similar, another one-page thing. I don't remember what the topic was. Here, we can look it up here real quick. Looking at Python 2 versus Python 3. We're going to be using Python 3 in here, but both of them are currently supported standards. At the end of this year, everything's moving over to Python 3, but there were so many things written in, and you'll read about this when you look into these, but there was so much stuff written in Python 2 when Python 3 came out, and there's incompatibilities between the two, that Python.org kept supporting both. So most classes, most new project that you're starting today would be written in Python 3. But there's some older software that's out there that might be managed that is still in Python 2, but now they're being forced to convert it over to Python 3. But again, a one-page paper asking you to look at those two, understand the differences, that kind of stuff. All right. And then we see coming into the middle or end of next week, we'll have our first actual program that runs. So by that point in time, you should have your Linux environment set up, ready to start writing stuff. Cool? All right, questions about any of that stuff? And like I said last time, all the assignments for the entire semester are already up with due dates. A good way of viewing that, and I'm not necessarily encouraging you to work ahead, but if you wanted to work ahead, you can. But I would keep things relatively fresh in your mind, because I'm going to pace class at the same pace as these guys are going. But if you happen to know that you're going to have a lot of stuff to do on a certain week, I try to give you some breaks on like midterm weeks and stuff like that. But if you happen to know you're going to have something big coming up, you can do something early if you wanted to. A good thing you can do that lets you visualize this. Let's see, which thing is it under? I thought it was under tools. There's like a course calendar, yeah. So under tools, you have something called a course calendar, and this will populate, and it shows you, this is currently the wrong course. It's a similar course, but not the course. You are... Yeah, this one, okay. So you see on Friday you have drill homework number 1 due. Sunday night, Bible homework number 1 is due. Monday, drill homework number 2 is due. Next Friday, the first project is due, which is Hello World. Pretty simple thing, but at that point you'll know that your development environment is working. So this is a good way of going and visualizing what's going on in class and when stuff is due and that kind of stuff. Make sense? All right, questions about any of that stuff? So everybody's going to have their one-page paper turned in before class starts on Friday, submitted via Blackboard. Everybody's going to have their Bible homework submitted by midnight on Sunday. Everybody's going to have their one-page paper due turned in before class on Monday. And I'll yell at you next week about what you need to turn in, but that gets you a couple of classes forward. All right. Now, having said all of that, I know I keep clicking it. Where is it opening? Yeah, I'll just click it again. So and I also have the link for the YouTube lectures as well as the slides. They're both up on Blackboard now, so those will update automatically. I have the slides shared, so as I add new slides, those will update, and then each day the lectures will automatically show up under that playlist for streaming lectures if you want to go back and review anything we do in class. I've also heard that it's a good way of falling asleep at night, stuff like that. We'll talk about that next week. So I'll go ahead and click on course book here. Go ahead and read chapter 0 and chapter 1. You'll want to get those kind of under your belt by Friday next week. These aren't something I'm going to grade. I also typically don't test random stuff out of the book. If there's something I think is important, I cover it in class. All right, so you don't necessarily need to, hunt through the book to make sure you've memorized every little stupid detail of things that may not be important. If it's important, I'll cover it. But keeping up with the pace of the class, get through chapter 1 by middle of next week, let's say, something like that. Okay. Everybody's good with all that? All right, so let's keep trucking then. Okay, so we talked last time about this idea of why computer programming is hard in general, and it's that we're too good at solving problems, and we have trouble slowing our mind down and writing that recipe, writing those individual little baby steps for solving a problem. I'd probably use some example about like, if you were baking something or, following some recipe at home and you skipped a couple of steps, it's probably not going to taste all that great. So those individual baby steps are pretty important. Computers need it to the extreme. We have to articulate every little tiny step to solve a problem in an unambiguous way. The computer's not going to guess what we mean. All right, so I promise you, when you are working on your programming assignments and you get 4,000 errors, which will happen for a while, you'll have tons and tons and tons of errors. When you say to yourself, oh, there's something wrong with my computer, I promise you it's you. There's something wrong with your code. Okay, you've indented weird. You've written an incorrect statement. The most frustrating thing with beginning programmers is when it doesn't yell at you about your code being wrong, your code just doesn't do what it's supposed to do, right? You follow instructions for lasagna and end up with a chocolate cake, that type of thing. All right, so keep in mind there's multiple ways that you can mess up with your programs. You can write bad syntax where the Python will be happy to scream at you and say, I don't understand what you're trying to do. I'm expecting this here. You gave me this. So one of the skills you're going to learn is how to read those error messages. And because something you're going to want to steer clear of is this idea that a lot of beginning programmers fall into, or this trap that a lot of beginning programmers fall into, and that is you see an error message and you don't read it. You just immediately go back to your code and start changing stuff. And then in the end, what do you have? You've tried every permutation of those 7 lines of code until it finally works and you have no idea why it works. All right, so whenever you make a change to your code, it should always be, at the very least, an educated guess. You've read the error message, it's screamed at you about X, Y, and Z, you've made a change relative to what you think it's complaining about. All right, so kind of rule of thumb to keep in mind, and we'll keep reviewing that as we get farther into it. All right, so programming is hard because we are too good at solving problems. So one of the skills we're going to have to learn is how do we break things down in little tiny baby steps, understanding this is also going to be a constraint on how difficult the problems we solve with computers can be, right? We used the example last time about walking, and walking is an incredibly complex thing. We can't write a computer program to make a computer walk. We, as a human being, we can't articulate every tiny little step that goes into walking. As babies, we kind of just figured it out, right? And now that's why we have this new field in computer science with artificial intelligence and machine learning, where we're trying to mimic the human brain in some sort of simplified form and saying, here's what we want you to do. We know this is the input you're going to be dealing with, and this is the desired output. Figure it out. And that's going to be kind of a new forward-thinking science in computer science, and hopefully going to allow us to solve very, very complex problems that a human being may not be able to articulate to a computer. Give it the baby steps to do it. All right, so that's going to be that's an exciting area that we're going to in technology. And if you want to see how that ends up, just go and watch those Terminator movies or The Matrix, any of those. It all works out great for us. It doesn't actually, but should be fun. Could be a good ride. All right, so I mentioned last time, how do human beings solve problems? I abstract this to 3 things. We use our memory, we ask questions, and repetition. If we're missing any one of these things, we're really, really debilitated on the types of problems we can solve, right? A lot of movies make fun of it, right? But, people with like short-term memory loss, something like that. walk into the room, it's like, hey, I'm Mike, and then, the person doesn't know who you are 2 seconds later. And some of you have seen this with dementia and things like that in your families. We very, very, very much rely on our memory for solving problems, right? It's an important concept. We constantly ask questions, so much so that we're not even aware we're asking them anymore. Okay? Same thing. We tend to operate with repetition. What I'm promising you is that every single programming language you ever run into will have facilities for these three things. 100% of them. So what you're learning in here is computer programming as a skill set, not Python. We happen to be using Python as our example language. Make sense? I could have picked any programming language. We picked Python because it's one of the cool kid languages. If you just do a Google search for top programming languages, you're going to find, in some order, Java, Python, C#, C++, something along those lines. Apple would say Swift is going to be up there, but it's probably like 8 or 9. But we use industry standard languages, so you'll be messing with those different languages as you go through the different classes in our department. Okay, so with all of that in mind, I want to draw a little bit of a picture here, because whenever we're dealing with a new programming language, we want to contextualize where it lives in the evolution of languages. And I'm going to kind of start with a language. This guy's roughly late 60s. 1968. We'll just throw that guy out there. I'm going to go ahead and draw the whole chart, then we'll walk through it. So from C, we went to C++. C++. We went to Java. Java. There was a little bit of a lawsuit. We got C# out of that guy, and we'll talk about that here in a few minutes. Over here, we have a language called Objective-C. And then later on, we have a language called Swift. And I'm going to label these guys as our native programming languages. All right, so these are the programming languages that are built for running directly on our hardware. That'll make some more sense later. Let me just label it that for now. Okay, we're going to focus on these languages initially here, even though you don't see Python in that list. You're going to see Python here in a second. So I'm going to create another column over here, and I like to put at the top of this guy maybe Perl. Then PHP. We'll go ahead and put Ruby in there. We'll throw Python there. And then I'm going to throw a technology down here called Node.js. We'll talk about this real briefly just to get a feel for where these guys fit. And then out here, I'm going to put a language called JavaScript. I actually put it over here to the side for something I'm going to talk about here for about the next 10 minutes or so, let's say. Okay, so we're going to call these guys our web programming languages. Although some of these guys have matured to the point that they are now being used for other things outside of internet stuff. All right, so let's just assume that modern programming has a great, depending on where you are in this list, grandparent of the C programming language. So all of our modern languages take a lot of their cues from C. Keeping in mind that all programming languages are going to have facilities for those three things: memory, asking questions, and repetition. Every one of these guys has those things in it. But at some point, we have to pick a syntax to base things on. So if we think about natural languages, English, French, German, things like that. We have some core historic languages that these guys are based on, right? Like Latin is the base for some of these languages, things like that. So we would say that all of these programming languages here kind of base themselves on top of C. So C is kind of like Latin when it comes to the programming languages, let's say. Okay, and what does that mean? It means that the C programming language's approach to how to define a variable, how to emulate memory, ask questions, repetition, made enough sense that these newer languages decided to mostly copy the syntax for doing that, the words that need to be written for doing that, even though they've added some new functionality that make you maybe want to use Java over C, for example. You know, think of it as like the newest release. Why do you get a PlayStation 4 rather than a PlayStation 2? All right, you know, it can run the latest, greatest stuff, all that jazz, right? And they still sell them in the stores. So, in any case, you could kind of think about these things like that. But all of these guys will have facilities for memory, asking questions, and repetition. Okay, so I'm going to start over here just for a few minutes, and we're going to create a quick slide. How does the internet work? Notice I did call these guys our web programming languages. All right, so this class isn't so much about what we're about to talk about, but it gives us some context for where those languages came from. All right, one thing I'll mention that I do before the midterm and the final is I go through the slides, which is the same thing I do when I go and write the tests, and I kind of point out the areas that like this is probably going to show up on the test in one form or another. I would say it's very rare in my exams that you have a question that came out of left field. You pretty much knew it was coming. All right, so we'll go back through this before the exam, and I'll point out slides you should pay extra attention to and which slides are kind of supporting material for something else. All right, so don't necessarily try to memorize anything. I want you to focus on the bigger picture here for a while. All right, so we have this global idea in computer networking called the client-server model. All right, and one thing you're going to learn about in computer science, Dr. Locklear refers to it as this idea of the grand ideas of computer science. Whatever you call it, what you're going to find is every single computer science class you take is going to be kind of looking at the same thing, maybe through a different angle. All right, so we're going to have tasks or concepts that are repeated from different angles in all of your classes. So we say this is the client-server model. This is something that might show up in a networking class. All right, well now we're going to evolve this a little bit and say this is our web client, and this is our web server. And we'll make those guys a different color here. Okay, now, can anybody give me an example of what a web client is? What is a web client? What's the client application that you use to experience the internet, the web? Chrome, Edge, Safari. It's a web browser, right? So that's our web browser. Pick your favorite web browser. That's what that guy is. Okay? And we'll make that yellow. Now, less of you are going to be familiar with these. Anybody know a popular web server? Apache, IIS, these are basically your two big ones. If your web server, if the computer that's running your internet is Windows, it's running IIS, Internet Information Server. If it's anything else, probably Unix or Linux, it's running Apache. Doesn't matter, they all do the same thing. All right, so this is a computer running a piece of software called Apache or IIS. This is a computer running a piece of software called Chrome or Firefox, whatever. Make sense? All right, so now what's the relationship between these two guys? Now your web browser lives on your computer. This guy lives someplace else. If you go to www.google.com, you're talking to the web server that lives at probably one of the warehouses where Google has their stuff that's geographically conveniently located to you based on, you know, where you are in the world and speed of internet connectivity, that kind of stuff. But computer that's somewhere else, this is on your computer. And these guys are going to talk to each other. All right. So here's something called computer protocols. Anybody know what protocols are? One thing we run into in technology is we have a lot of times fancy names for easy things because we like to make ourselves sound smarter. Protocol is a synonym for a language. So for instance, right now we're communicating using the English protocol. All right. Does anybody know what protocol web browsers speak to web servers with? Okay. Well, at some level, anything we're dealing with computers is going to be a binary, but we need to be operating at a higher level than that. But that's not. It's going to be zeros and ones at some level. Go ahead. That's going to make it onto the slide. Not quite there yet. Go ahead. HTMS. Oh, go ahead. HTTP. HTTP. Now, all of you have seen that before, right? You type in google.com, the browser hides it now. Is there a way to get me? It says http://www.google.com. That's what it'll show up there. It's speaking the HTTP protocol. Okay? So we've seen it for years and years and years in our web browsers. It looks like they've abstracted it away because none of us type it, right? When you go to your web browser, you don't actually type http://. You don't do that anymore. But we've seen it before, right? Okay, so the language, the protocol that's being used to communicate between the web browser and the web server is HTTP. Now, the details of that language are unimportant to us. That's not a programming language, that's a communication language, just like English is. So, web browser says, hey, I want the web page hello.html. Server receives that request in HTTP and says, okay, let me go find it for you, and it ships it back to you. All right, so what kind of information does a web server serve to a web browser? Somebody mentioned it a few minutes ago. HTML and what? There's a secondary thing that's there. CSS. It's actually a tertiary thing that's there. Okay. One more thing. It's on a previous slide. It's on this slide. This guy right here, JavaScript. All right, JavaScript. Now I'm going to close a loop here for us. I mentioned that 100% of programming languages, keep in mind I'm saying programming languages, not languages. Languages come in all sorts of shapes and sizes, right? 100% of programming languages will have facilities for memory, asking questions, and repetition. A lot of times when I might ask somebody, oh, what kind of programming languages have you had? It's very common for somebody to spit out HTML. How many of you have ever messed with HTML in here? Some level, high school, you wrote a simple web page, something like that, right? Okay. Now, many people would claim that HTML is a programming language. It's not. So if we think about HTML, I call this guy a data representation language. All right? So this is a tag-based language for representing the contents of a web page such that a web browser can parse it and turn it into pretty pictures and text. All right, so it's a way of sending the contents of a web page over the internet in a bunch of text that a web browser can then convert into something that looks good. That's what HTML is. Does not have variables, conditionals, loops. Okay? It doesn't have facilities for those things that I mentioned are requirements for programming languages. That doesn't mean that HTML sucks. It just means it's not a programming language. Now, how many of you ever been on a web page where you type some stuff in, there's like a web form or something like that. You type some stuff in, you hit a submit button, and then it yells at you and says, you must provide an email address, something like that. Seen that before? Okay. Now, do you think at some level there it's saying, if they did not put in an email address, scream at them and say you have to put an email address? Does that sound like questions being asked? It certainly does. And I'm telling you, HTML can't do that. JavaScript accomplishes that. So this here is the programming language that our web browsers know how to run for the dynamic aspects of our websites. Okay? Usually these things it's used for form validation and things like this. All right. CSS is a power tool for making all of your web pages follow the same color scheme and things like that. So if you want to make some sort of change, you change it in the CSS and then it changes the entire website instead of you having to go in and edit stuff on 50 pages on a large enterprise website or something like that. All right, so the web server is serving a document that is filled up with HTML, CSS, and JavaScript. That's what it does. Okay? Now, sometimes when we request, so when we do a request with HTTP actually has 4 functions, but if we're just talking about web servers here, we're using something called a GET request. The GET request is one of the 4 things that HTTP knows how to do. And so we might say, get me index.html. And it's going to look at the last part of this, and that guy's called a MIME type. It's going to say, what kind of file is this? Web server's going to look at that and say, what kind of file is this? And since it's an HTML file, the web server knows that, oh, that guy is already good to go. I found him locally here, and I can just send him back to the person who requested it. Make sense? Now, what if we said get index.php? Come back here. Notice I have a language listed over here called PHP. Okay, this is a programming language that's in my section for web programming languages. It was a language that was born based on C, but born to be a web-based language. Still a generalistic programming language. You can solve any problem you can solve with general purpose programming languages using PHP. But PHP has some power tools in it that make it very convenient to use for web stuff, let's say. All right. So having said that, if the request from the web browser is saying, I want the contents of page index.php, this web server here is going to go and look up. It's going to, it has some files over here. So it's going to have a file maybe called index.html. It's going to have a file called index.php. So it gets the request for index.php. It goes and looks at its file system and finds that file. And it looks at the extension on that, the MIME type of that file, and says, wait a minute, this guy has a PHP extension. The dude who's requesting this needs me to give him HTML, CSS, and JavaScript. We're going to have to pre-process this file. I need to run this program and get the answer, the output of that program. So the output of this program will be HTML, CSS, and JavaScript. because ultimately that's what the web server is sending to the web browser. That makes sense? So this is a computer program that's going to have to execute on the web server to get its output, which will be HTML, CSS, and JavaScript, so that we can send that back to the web browser so we can show it on the screen as pretty pictures and text. Make sense? But if it was an HTML file, no pre-processing has to happen. Similarly, we might have a file, index.py, Python file. Also needs to be run on the server. Output of that file, output of that program will be HTML, CSS, and JavaScript. It'll send the result of running that program back over the internet. Make some sense? This is how the internet works. This is how at least the web portion of the internet works. Your web browser requests pages. The web server looks up that page, decides, do I need to do something with this before I can send back HTML, CSS, and JavaScript, because that's all your web browser knows how to work with. So ultimately, the server spits back HTML, CSS, and JavaScript. Make some sense? All right. So these languages over here all exist for writing stuff that lives on a web server, is executed by a web server, ultimately outputting HTML, JavaScript, and CSS for consumption by a web browser. Okay? Now, I'll kind of give you a little foreshadowing thing here. Chapter 12, when we get to this, called web scraping, we'll be writing Python programs that talk to a web server, which sends us back HTML, CSS, and JavaScript. And rather than showing it inside of a web browser, we'll have our program go through and pull out the interesting pieces of information from it and maybe do something with it. Okay? Let me give you an example of that. So in the early days of the Apple App Store for iPhone, so this would have been, what, like 11 years ago? First year of the, when iPhone was out, there wasn't an App Store. It came out the second year. And I wrote several apps for the App Store, and I had the first real-time stock quote application on the App Store. You know, now you can go and download, an app from your bank, E-Trade, Chase, whatever, and, look at stocks and things like that. But they didn't exist day one because it was a toy, right? The App Store was a toy. Well, back then we didn't have tools that software developers could use to go and pull stock quote information. So I went to finance.google.com website, finance.google.com. Brings up something like this, and now if I just click on Apple, let's say, this URL up here, so this is my GET request. Somewhere in here it'll have AAPL in it, whatever. But I can build this dynamically, and ultimately it gives me a page that looks like this. And if I say view page source, this is HTML, JavaScript, and CSS. That's what's in this hodgepodge of crap here. Okay, that's what the web server sent back. Well, rather than showing this in a web browser, my iPhone app took this wall of text and went through and picked out current price of Apple. And then I showed it on the screen as the current stock price of Apple. And then every 5 seconds, I hit this page again to get the updated current price of Apple, to the demise of your battery life. All right? So that would be an example of web scraping, where we're going to use something to make an HTTP request to a web server, get the result, but instead of letting a web browser that was built to convert that into pretty pictures and text, convert it into this guy, I'm going to instead use that data behind the scenes and scrape out the pieces of information that are important to me. Make some sense? Okay, so that's, again, computer programming, this is going to be our superpower. It's a tool that we can use to solve problems. And if you look at the title of this book, I really need to figure out which tab that's in, don't I? Nope. Nope. We'll just open it again. See, what does it look? It's one of these. Okay. So this guy's called Automate the Boring Stuff. So one of the things we're doing is we're telling our computer what to do to automate tasks in our life. Right? That's what computer programming is all about, because human beings, we only want to spend our time doing certain things. All this grunt work stuff, looking through hundreds and hundreds and hundreds of characters like that, that's beneath us. That's the job for a computer. Make sense? All right, so this is how web browsers work. Now, how many of you have heard of these technologies? Ajax, jQuery. We'll just leave it at, let's do Angular. Leave it that. We'll put one more. You probably heard of React. Any of you heard of any of those before? 2.25 people? Okay, what do they do? Do we know anything about them, or we just heard the buzzwords? Okay, how many of you have ever, well, we just saw it happening on this page, our internet page, whatever, I closed it, I guess. But how many of you have ever watched like a sporting event or something like that, and you have a web page open and you rely on, you're watching the Packers game and you're relying on the score to update automatically? We've seen that happen, right? Okay, we just saw the Apple stock price sit there and tick, pulse on the web page. Well, historically, we used to have to go up here and hit refresh, tell it to reload this page to get the updated score. Now the page does it itself. All right. How is that working? Well, in the early days, that was done through a technology called Ajax. Ajax is, so all of these guys are JavaScript libraries. So some smart people wrote some special code in JavaScript that runs in the web browser that does things like that. Automated a certain section of your website, because the whole page doesn't keep reloading, right? When you're looking at the current Packer score, it's just that little square up there in the upper right or something like that where the score updates. You know, you don't see the entire page flashing, or you're sitting here reading stuff and all of a sudden the page refreshes, you're back at the top of the page. Only that one little part of the page changed, right? So Ajax allowed your page to kind of be alive and go and do stuff in real time while you were sitting there using the page. Then jQuery came out. What was jQuery? The same thing as Ajax. It just had some tools built into it that allowed the programmer to more conveniently walk the document object of the web page to get to the section of the page that you wanted to update. Just made it easier for the programmer to get to that section, where Ajax, it was kind of like, you know, you were kind of digging through the weeds to get to the 3 or 4 lines of code that needed to change to update the contents of the page. Make sense? Okay. What did Angular do? Angular did the same thing, but added two-way communication. So now you can make changes on the page. You can click on something on the page, and it goes to the web server, gets the result, and only updates that one place on the page. So now the web browser can talk to the web server back and forth, only updating certain parts of the page. Angular is made by Google. React does the same thing. It's their competitor from Facebook. All right, but all of these guys are JavaScript libraries using that same tool, that same programming language, JavaScript, to solve the same problem better. Right? It's evolved the solution, allows programmers to more easily get to those aspects of the web page. All right, now I'm gonna throw something else in here. So we would call this guy client-side programming. Kick this down a line. So anything that's happening over here would be considered client-side programming. If you're a developer working on that stuff, anything happening over here would be called server-side programming. Modernly, we have synonyms for these. Anybody know what we might call client-side programming today? Probably seen it if you've looked at, available jobs in computer science or something like that. Go ahead. How about front end? Might be called a front end developer. So jobs that are front end developer jobs mean you're writing stuff for the web browser. Make it look pretty, have the pictures, but you're going to still leverage JavaScript. So you're not a programmer. Okay, you're still going to be writing some code, but your job is kind of a hybrid. You're a programmer, and then you're also somebody who's got to make it look good. Make sense? And then the other side of that coin is this is a back-end developer. Okay, you're writing stuff that runs on the web server behind the scenes. Just has to work. Doesn't have to look pretty. That makes sense? Now, common thing we run into in the computer science world is these folks over here call themselves real programmers. These folks over here don't. They look at themselves as front-end developers. These guys would look down on these folks, say they're not real programmers. If you had to write a really complex piece of software, a video game, something like that, with really difficult logic behind the scenes, algorithm stuff, very complex algorithm. If you had to pick teams for this, you might have a better chance of getting somebody very capable of that from this group. That isn't to say that top-tier programmers don't exist in this group. But I would say this group of people is somewhat rarer to have a very talented person over here, because you're looking at somebody who has two, in many ways, conflicting skill sets. This person needs to be able to program, and they need to be able to make things look good. And in many cases, the people whose mentality is a programming-based mentality aren't necessarily great at making user interfaces look good. So in many cases, these are kind of superheroes over here. Now, a lot of times what you end up having in this industry is a front-end developer ends up being an artist who then gives all the artwork to a back-end developer who will spend some time putting it together in a web page for them. So that's the person over on this side that maybe doesn't have the programming skill set, but is really good at making things look good. All right? But understand that this world takes all of those people in order to make a web page, or in order to make a user application desirable, right? It doesn't matter how great your product looks or works. If it looks like crap, nobody's going to want to use it. All right. Now, if it looks really good, they expect it to at least work pretty well. Something along those lines. All right. Questions about any of the stuff we talked about today? All right, so next time we'll pick up, we'll continue. I'm going to finish up our little discussion here on Node.js. That'll only get to take like 5 minutes. And then we'll dive over here to the native programming language evolution and see how we got to where we are today with that. And then we'll start getting into Python syntax stuff. So in the meantime, do your homework for Friday, start reading chapters 0 and 1 from the book, and I will see everybody on Friday.